I think we are ready to start. Okay. Good afternoon, ladies and gentlemen. My name is Borko Novakovic. I'm a program manager on Database Systems Group. I'm part of the team for 2 years who has been working on Query Store feature in SQL Server 2016 and Azure SQL Database. But before we basically start with the details about this topic, I'd like to see what you are made of. So how many database admins we have here? Okay, I kind of expected. Database developers? Okay, good. How many of you have been involved in any performance troubleshooting so far? Oh yeah, that's cool. So that's my audience. Great. So those are the session objectives, basically, and what we want to achieve today. First of all, I'd like to help you understand what is Query Store and why it is important for performance analysis. And also, you'll be able to see how to apply Query Store to your application scenarios, I hope. And finally, you'll get some details how it works, how to configure it, how to optimally use it, and what are the limitations. But basically, the following 3 takeaways will be repeated throughout the entire session. Query Store is a workload data recorder for your database, a component that continuously tracks and captures everything that is important for the performance of your database. That's one thing. For you, you should also remember that it is the starting point for any query performance analysis and tuning. And finally, Query Store is there to give you full control when it comes to application performance, regardless if you run your application on premises or in the cloud. Before I continue, I'd like to, in parallel, just set up the stage. I'll run something that will cause the problem in my test database. So, and while we are talking, hopefully we'll have something to solve, or at least to analyze. So, I want to also give credits to Query Store team and Connor Cunningham, who is an architect for this feature for a couple of years. Also, I'd like to say, I like to thank to Visual Studio Online team who inspired this session because they gave us a lot of interesting examples how Query Store helped them run their business, ensure optimal performance. Also, Bob Ward, who several times gave excellent presentation on Query Store, and I actually used some of his materials. Okay, so you probably know that having bad performance in your application is really hurts, right? And in most critical cases, it can be the situation that your critical application suddenly goes down. Entire business is stopped. Huge losses. The problem is huge, and you need to react immediately as soon as possible to at least mitigate the problem. That's the most severe situation that can happen, but also performance issues can occur in other different scenarios. For instance, you upgrade the database platform because you expect to get better performance, better scalability, and then you end up in a situation when your original application is actually behaves worse than previously. Also in Azure SQL Database, it may happen that when you scale up or scale down your database, you are using different service tiers. You can experience different and strange performance issues. In some cases, it really depends on your application patterns. And finally, in some cases, performance can be experienced as a big variability of the response time, of the throughput that your application has, which means that you cannot actually rely on your application. You cannot plan. You do not have sustainable and predictable throughput, sustainable and predictable performance. All of these situations are something that needs your immediate attention. But you basically know one of the things that is really problematic when it comes to performance troubleshooting is that most of the people are not well prepared for the situation. When problem occurs, then typically they don't have enough data to react immediately. Yes, they will probably start tracking data. They will start taking DMV snapshots. They will start capturing X events or whatever. But basically, in that very moment, they're without data to react. So as a result, time to detect and time to mitigate problem are unacceptably long. That's one problem. And as I mentioned, if you are relying on querying DMVs, it may happen that when someone reports the problem and you go to the production server and query DMVs, at that point everything looks fine, which means, oh, what is going on? But the problem actually happened and disappeared, and you need to wait for the next occurrence, which is also a problem. And also, you know that some of the queries that your application executes against the database might not be cached at all, so which means you will not be able to find that statement using the DMVs. That's also a problem, so you do not have full information. Many people report that using X events is actually pretty difficult for them. It requires them a lot of knowledge, a lot of expertise, and they just avoid to use that technique. Although X events can help you greatly to understand what is going on. They will provide you with the greatest level of information. So even in case when you find the performance issue and you detect the performance regression, which means the query behaved well, and all of a sudden, due to plan choice change or something that is related to query optimizer change the performance, you were able to actually identify that situation, how to force a better plan, what technique to use. Of course, you can use plan guides or you can use plan hints, but again, these techniques are really complex and requires you to know a lot and to be very into the details, right? So traditional way of troubleshooting is related to complexity, and it's error prone, it's really slow. So typically you will end up writing a huge queries and then trying to analyze from that data what is going on. So query store actually was designed to solve that problem. It actually attacked all these weak points of the traditional performance troubleshooting in a way that is really a component that pre-collect and persist the data, all important data that you need for the performance troubleshooting data that is related to the query execution. Starting from statements, compile time statistics, all plans, and then very detailed runtime statistics. So having that information available, you can react very quickly. Query store actually acts and behaves as a flight data recorder, which means it has a couple of interesting properties. It does survive all crashes, which means even if your entire server is down, when you restart the server, query store data will be there. That's extremely important. It chooses and records really critical information, which means it doesn't record everything, but it records information that are really relevant for you. And it does that in a very smart way. And finally, it records data for the limited time, because not only that query store is there for you to provide important data, but also recording important data about query execution must not itself endanger the query performance, right? So the way how we design it, it's lightweight and records data for the limited amount of time. Of course, you can configure those parameters. So why query store is special when we compare it to other troubleshooting techniques? So it's really, it tracks information independently from the plan cache. So that's very important. It exists and it tracks information independently from the plan cache. And as I mentioned, it is able to survive different kind of a situation like restarts, failovers, server crashes, everything. Data is persisted and available when you need it. Finally, it really lowers the bar for the performance troubleshooting, which means that query store, not only that it's a rich repository when you can go and analyze the data, but also the way how query store exposes the data is very simple and intuitive. There is a UI, very nice UI that you can use, and using that UI, you'll be able to very quickly pinpoint the issue. And actually, in typical situations like plan regressions or high resource consumption, you have a UI-based tool that will help you determine where the problem is. And finally, it also lowers the bar for the solving the problem. I mentioned, basically, how many of you knows, without looking at the MSDN, to write a plan guide that applies a certain plan? Okay. You probably, I mean, yes, you need query store as well. But basically, the point is, with query store is a matter of it's basically one click of a button, right? Instead of writing a complex script, figuring out what is the plan, where is the plan, what is the plan handle, plan hash, and stuff like that. Very, very complex. A click of a button will actually solve you the problem. So there is really the difference between writing 1,000 lines of script and looking into the UI. So that's something that Query Store offers out of box, and you can use it and be more productive in your environment. Now, I'll try to show the first demo, how it looks like in the real situation using the Query Store. So here's the scenario. I'm an application developer and database developer in a company that runs a web-based, cloud-based application. And because I'm not a DBA, I'm not an expert, I'm a lazy developer. I like to proactively solve problems. So what I did, I actually set up the notification on Azure portal that will notify me if my DTU consumption, whatever DTU is, but it's important for me, DTU consumption goes above something that I consider as a limit, right? And when that happens, I'll be notified by the email. Dear customer, something goes wrong with your database. Would you mind to go and look what happens? And of course, I'll do. If I copy that link and go to the page, I'll save some time here. You can see basically that when I click on my database, and link will actually lead me to this page, I can see that my database is running at almost 100 DTU. So DTU is a blended measure that actually describes how much CPU, how much memory, how much I/O do you have within a boundary box that you bought on Azure. And there are different layers like standard service tiers and premium service tiers. And with each higher tier, you'll get more CPU, more I/O, more memory. But basically, DTU is really important because you are capped based on that blended mesh, right? So in this case, what does it mean for me? It means if I do not do something about this, I'll get customers calling me very soon. Because when I'm running at 100 DTU, 100% of DTU, that means the databases cannot process basically data and new requests. So, okay, what I'm going to do, yeah, I'll use Query Store because I've heard a lot of good about it. And the good news is I can connect my query store to Azure database, the same way as I connect query store to on-premise database. Everything that I use on-premise is available here as well. So you can see here that there is a new folder beneath the database with the predefined reports. Not only that, but Query Store was actually enabled for my database by Azure SQL Database Service automatically because guys in Azure SQL Database Service realized that having Query Store running in all databases in Azure is very, very useful, not only for customers, but only for Microsoft to improve the quality of the service. So when I go here, I have 4 different views, and since I'm in a problem of high resource consumption, I actually open these top resource consuming queries to see what is actually using my resources. It must be some query. It must be many. It may be many queries, but it must be something that is run by my application. Although this is a default view, duration, I'll use the CPU metrics because CPU really, it nicely reflects what happens in a system. And you can see that top 25 resource-consuming queries actually has one guy who is really, really bad. Of course, yeah, this is a demo, but it really happens in reality. It really happens, right? So typically, when you have a problem with the performance, it's 1 or 2 queries that are really bad. So this query actually was executed large number of times, but not only that, it actually produced and used a lot of CPU. Let me see, I'll try to focus my analysis, and I can use this nice UI basically to focus my analysis. Instead of looking 1 hour, which is default, I can actually take a look and see what happens in last, for instance, 15 or 10 minutes. It's very easy. I just change the configuration. And what I can conclude from this is that this query is actually executing using 2 different plans, okay? And obviously, this blue plan is not that good. If I go and point my mouse, I'll see that average CPU time is extremely big for this plan. And for this plan, average CPU time is much better, right? Why that happens? Basically, from this very from this statement, I can see that this is a parameterized query. And I can suspect that it's something that we know as a PSP or parameter sniffing problem. When you have parameterized query and when you have skewed data in your database, depending on the parameter value, when you reuse plan from the cache, sometimes you get excellent performance, sometimes you get very, very bad performance. And if you have skewed data, which means the distribution in one column is such that it's not uniform, it really can happen. Now, it's actually not a problem, it's a behavior, right? It's by design, since we are using cached plans, right? But when it happens, it can be really serious. And in some techniques for solving PSP can be different. We can force recompilation for the query. We can use some optimize for some parameter value. But in this very case, I don't have time to think about that, right? From what I can see, one plan is obviously better. I can just select the plan, the better one, which is plan number 3, and I'll just say, hey, for this plan. OK, that's all. And I'll wait for a couple of minutes to see if that will help me or not. Hopefully will, right? So that's the performance troubleshooting scenario that I'm doing here. And while I'm here, I can just briefly explain and tell you a couple of things related to the query store. So it's a database level feature, and you can learn and you can set it and you can configure it from the Management Studio or using the Transact SQL scripts. But actually, the default configuration that comes on Azure is good for a majority of workloads. If you want to control things, you can change some of these configurations. The most important is how much of data in your database you will allocate for the query store. And it really depends for how long you want to keep the history of data. Some people want to see history of data for a couple of days. Some people want to see history for a month. Some people even longer, but that's up to you. That's the next parameter, actually, that you can specify, which means if you specify the time-based cleanup, after some time, after that time, query store will automatically clean the data, which is excellent thing. But if still you reach the limit, then the query store will go to the read-only mode because you set the size limit. In read-only mode, it won't be collecting new statistics, but all these plan forcing that I mentioned will be still active. There are also two features here that might be interesting. My recommendation would be to keep them on auto mode. One is the query capture mode, which means what are the queries that query store captures. You can set to capture all queries, or you can set auto. Auto mode actually filters out ad hoc queries, right? Because those queries do not contribute much to the resource consumption. And in some cases, you may have a lot of ad hoc queries that are executed very rarely. They just introduce the noise into the analysis. You cannot focus on right things. So with auto, you'll just filter them out. And also, there is a size-based cleanup mode, which allows query store, when the size of query store approaches to the maximum size, it will clean the data regardless of the age, right? Because the idea behind this mode is when you set it to auto, query store will be always running in the read-write mode, always accepting and collecting the latest statistics, and then removing the oldest and less relevant statistics. So that mode is very, very important when you want to basically run query store continuously. Okay, so we will get back to this situation again to see if my plan forcing helped. And now I'll again switch back to the presentation. I want to give you a couple of interesting information when to use query store. And I think there's no better way of telling this story than hearing that from our customers. So we have one of our customers here. It is Jacob Ferenc. He's an architect in Oriflame, Sweden. He is coming from Czechoslovakia. Please help me welcome Jacob. Jacob will tell the story about using query store in Oriflame.
Yeah, hello. Can you hear me? Yeah. Okay. I just want one correction. It's not Czechoslovakia. It's Czech Republic.
Oh, sorry.
So it's a pleasure to be here to share some details how we use query store in Oriflame. So maybe I will just at first describe what our business is about. So Oriflame is a beauty company, and which is selling direct. We are spread over the globe in 60 countries. And the reason why I'm here is because we host our e-commerce site in Azure. And we use SQL Azure as a main database provider. So basically, this e-commerce site, just to imagine the size, currently I think last year there was more than 1 million visits, user visits per year. So the load is changing. We are like experiencing like peaks. There are sales peaks, and so this is where we really utilize Azure in terms of scaling. And like just to imagine the number of databases currently, like as it is written here, like there is a 60 tenants. One tenant is like one country. So all these some of these tenants are grouped to one database, but taking it together, we are running around 30 production databases and more than 50 non-production databases. So like what is bringing us, what is quite good on Query Store, it's bringing us some new, quite fast and straightforward tool how to monitor the performance of databases. So, because there are basically two streams which are coming to us. One stream is that we need to deliver the requirements from the business really fast. It's like really fast-paced environment. They are pushing on us like we need it right now. They need it sooner than they submit the requirements. It's usually, you know.
So that actually means that you need to develop your application very fast and you need to iterate very quickly, right?
Yeah, that's right.
Okay, so that's good from the development point of view, but
and
I guess
from,
it's
from
not
the
from
other
the
hand,
stability point of view.
yeah,
right?
from the other hand, there is the requirement like from the stability. There is zero downtime requirement, no slowness, or well, no slowness is possible, and so this is going to across to each other. So, like what one of the scenarios how we use the query store is that we during the deployment we monitor the database, like really checking the query store what is going on, and checking if everything is okay after the deployment. So. Let me just say one example. It was, I think, 1 month ago. There was the application prepared. We put it into the production. We monitored it. And then we suddenly realized that some of the databases were utilized quite a lot. It wasn't hitting like 100% because we usually pick some off-business hours. So, but still, we saw like it has risen so for some time. And so it was quite easy. We go to the query store. You can use the UI, as Borko said, or we have some queries like to, you know, when you know it a little bit more, you can just write a query, you can adjust the query, and we find out that there was some business logic change, and some query has changed just a little, but the touching the data through different views. So we realized there's an index missing. So we added an index, and all this operation from that we realized it, and to add the index into the production, it took, I don't know, 20, maybe 30 minutes. So it was a really fast way how we identify the issue in production and solve it before a customer realized it.
Okay, yeah, that sounds excellent. Thank you. Thank you, Jake.
Thank you.
So we have some other, of course, using Query Store. By the way, Query Store is currently running on around 1 million databases in Azure SQL database. So it's really a huge footprint, and we do hear every day that people utilize it in everyday operations. So the Dominion Enterprises has similar pattern. There are also SaaS vendor running their business in the cloud using Azure SQL database. And again, their scenario was specific. They migrated application from on-premises to cloud and used Query Store in early days to detect all anomalies and regression that happened because they migrated the existing application without any change, all the queries without any change to the cloud. After a couple of days and weeks, they were able completely to stabilize the performance. So they actually use the Query Store in a very similar way, running as a monitoring tool and a tool that helps them detect problems very, very easily. Now, our third customer is Channel Advisor. It's e-commerce. They provide e-commerce solutions and publish data for e-commerce sales. And basically, they've recently moved their on-premises application to SQL Server 2016, and they use Query Store in 2 ways. First, during the upgrade process. I'll explain why Query Store is important during the upgrade process, how we can actually greatly help you to make the upgrade process very stable and fast, and then they continue to use Query Store in everyday operations. Basically, they completely replaced existing third-party solution. I also want to tell you a story about the Visual Studio Online. I mentioned them in the beginning. So they are also operating as a SaaS vendor. They are running a lot of, more than 100 of databases, highly packed databases. In every database they have, depending on the region, they have a very large number of tenants working against in the same database. And it's very important for them to keep their databases busy, to actually have business that is running good, right? But at the same time, those databases must not be overutilized. So they are operating at a very, very critical margin, right? Now, here is their real case that they share with us, how Query Store helped them to utilize, troubleshoot the performance. So again, they have a similar system as I described, tracking the CPU consumption in their database, and they are actually looking for the CPU spikes. One bad day started with untypical CPU spikes, and their DevOps team actually uses the Query Store by default as a tool for troubleshooting such cases. Here is what they've been able to learn analyzing their case. First, when they look at the top resource-consuming queries the same way as I did, they figure out that the most expensive query actually has only one plan, which means it is not the situation that I showed previously. They cannot use plan forcing. It's only one plan. Something is different, right? But it's very important. They just eliminated that possibility and continued the investigation. What they done after that, they basically compared what they called a good day versus bad day. Like today is a bad day, performance is bad. Yesterday everything was fine. They, for the critical query, compared the execution count. And they've seen that execution count is increased, which might lead to the actually worse performance. But they wanted to drill down and see more specific details. Total CPU, on the other hand, was increased more than 600 times. So it must be related, something must be related to the individual execution, because if you increase the number of execution only 3 times and overall CPU goes 600 times, something is related to the individual execution. So they basically decided to go and analyze this query to see the necessary details. The query that caused really increased CPU spikes was the query that was deleting from some notification table, and they analyzed the query text and everything. And they said, hey, perhaps this delete today deletes much more data than yesterday. Probably that's the problem. Can I figure out that out from the Query Store? And luckily, yes, Query Store gives that information as well. So not only that you have plans and some compile time statistics, but you have very useful and different runtime statistics. An average row count per query, per interval is available for them. So what they concluded? They concluded, OK, this query today, during the bad day, deletes 4 times more data than previous day. But that still cannot explain such a big performance regression, right? So yes, it's executing more frequently, it deletes more data, but basically performance regression is much worse. So they said, hey, this must be a data shape issue, something related to how we organize the data. They also took a look at the table size and concluded, hey, table size is similar as yesterday. There's not much data to be deleted. The size is the same. And then go into the execution plan and analyze the plan. And basically concluded that the business logic they implemented is such that they actually have subscribers and they send them notification. But after some time, when subscribers unsubscribe, they actually want to delete notification. What happens is that number of notification in the bad day was the same as the previous day, but number of unsubscribed people was much, much bigger. So basically, as a consequence of that, and they concluded that looking at the plan, because there was a cluster index delete in the plan, they concluded, hey, today we do have much more subscribers for which we need to delete notifications. And how they solved that? That was actually an application problem that they actually went into the application and figured it out. And basically, they rewrite the query in a way that it performed better. But the conclusion of this analysis and this story is actually the following. Query Store helps you focus investigation. It will very quickly point you where the problem is, and then you'll save all your time, energy, right? It eliminates the need to breadth-first search. And also, it clearly say which avenues you should not actually take, or which approaches you should just avoid, right? It's a simple and it helps them build very simple and intuitive and iterative process. They start at a high level with the database resource consumption. They try to see either top-level resource consumers or regress queries, and they basically do baseline comparison. Today is a regression. Yesterday was a good thing. Let's compare two and see and try to get some conclusions. And then finally, if they are not able to solve the problem, they go into the query plans and all the details. Also, the good thing is they were able to finalize and finish entire analysis from the query store using the SSMS, no need to use different tools, and finally, tuning effects are immediately visible because when, as Jacob said, when you apply the mitigation, basically it's immediately visible in the query store. You can use the query store as a tool to verify if your mitigation was successful or not. Another scenario that is also very useful and important, and we do really highly recommend Query Store here, is when you upgrade to SQL Server 2016. You probably know that when you upgrade to the latest version of SQL, due to changes that we apply in Query Optimizer, your application may not be working as you expected. And this is because with the latest database compatibility level, you by default get all these Query Optimizer changes, right? Now, there is a process that you can follow using the Query Store, iterative process that will actually prevent performance regression. And here it is described. So this is the recommended approach. So if you upgrade your database to the SQL Server 2016, our recommendation is to keep database compatibility level for some time on the level that you had prior to migration, right? So effectively, you stay with the Query Optimizer that you ran prior to upgrade. But now you have new features, and Query Store is one of these. Then turn on the Query Store and capture plans and statistics for some time, long enough to capture the baseline. So basically, that way you'll get, hey, this is the performance baseline of my system running with the previous version of the optimizer. Then move compat level to the latest one and use Query Store to detect issues. Because the same way as I was able to find and detect and solve the issue in Azure using the Query Store, you'll be able to do that after upgrade. And not only that you'll be able to understand what are the regress queries, but also using the plan forcing, you'll be able to say, hey, although I'm at the latest compat level for these couple of queries, just use the previous execution plan, and that's fine. So that is actually not only a way to quickly figure out what can go wrong with the upgrade, but also to quickly solve the problems that you may experience with the upgrade. So if I summarize here all scenarios, basically with the Query Store, they go into two groups. One is the protection, and it's more like when you are in the database admin role, you want to make sure that your system is running predictable. You'll probably go and look regress queries, resource-consuming queries. You'll use it to control and de-risk the upgrade, and also any change verification that you do in the system. Like prior to new application rollout, Query Store captures the baseline. After the application rollout, you'll have the deltas, right? But also, it can be used in more advanced scenarios, like proactive application optimization. For instance, you can easily use Query Store to detect if your application is running ad hoc queries and what part of your application running ad hoc queries. You might want to optimize those queries, to parameterize those queries, or actually to rewrite or change the client application. You can use Query Store to understand the different execution patterns like what are the queries that are being executed every day regularly versus those that are executed only during the weekends and only by end of the month and stuff like that. So you can optimize your workload at a high level. And finally, you can analyze the execution variability and try to address with application changes. Majority of these scenarios are well described at MSDN. You can go and take a look. Now, I'd like to tell something about how it works. But before we go into that part, do you have any question related to the usage scenarios? The question was if we run cross-database queries, the cross-database query, will it show in both databases? It will show in the database where your execution context is. So you are connected to one database and reference another database with a three-part name, right? So the query store in the database where you are connected to will capture the information. Yeah? Yes, it can help you, although you cannot use query store to have all precise information. It can be an indication of that situation, right? Sorry, can you just repeat the question?
Sure. If the database is being locked in disaster recovery site and we force a plan,
Okay.
what happens if we activate disaster recovery? What happens to those forced plans?
Yeah, that's a good question, and I need to follow up on that one. So yeah, let's basically let's exchange emails, and I'll send you information. I don't know the answer to that immediately. Yeah. Yes. Structures in the database recovery.
Right. So if I do database recovery, is it non-reset?
No, basically, no. It stays there, right? So that's no impact. It's basically orthogonal to features like recovery, backup, replication, and stuff like that. Yeah. Just to comment. Query store data, when you backup and restore, you get the query store data on the restore. Just to mention that part that I maybe didn't explain also. Yeah? Okay. You mean alerting on top of query store? I see. So the question was, do we plan to enable monitoring on top of query store? It may, yeah. Currently, we do not consider that possibility. Yeah. Although in Azure, when you run your databases in Azure, there are built-in alerting mechanism, as I showed in the demo, so you can actually combine that and the query store to perform end-to-end performance monitoring and troubleshooting. Yeah. Typical overhead of the query store, that was the question. So typical overhead that we see is really negligible. Like, and I said that based on the performance test. I said that based on databases running in Azure. It's really like 1 to 2% at max, right? But it doesn't mean that a query store will have 1 to 2% for every application. You can run the application that can actually, where query store can have a significant performance impact. But really, that depends. Like, as I mentioned, one case is really ad hoc workload. When you generate new queries, and then that's really a pressure to the query store because all these new queries will be recorded as separate entries, and then it really had impact. But basically, if you are running well parameterized workload, a couple of hundreds or a couple of thousand of different queries, which is pretty decent amount of queries, and then you can have millions and millions of execution, then the overhead is actually invisible. So the majority of the overhead doesn't come on the execution part. It comes from the compilation part, right? So by default, yeah, they are considered as a different queries. Like, when you have literals in your query and you do not enforce parameterization, then it will be recognized as a different queries. When you have database level parameterization and you effectively parameterize those queries, then they will be stored as a single query in the query store, right? So there is this article that I shared with you, the link on the scenario slide. If you go and follow that article, there is actually very well described the case, how you can use query store to detect that you are running ad hoc workload, right? And what is the, let's say, quantitative measure of ad hoc part, right? How many queries, what is the resource consumption, what is the compilation consumption, and stuff like that. Okay, I'll continue with how query store captures and store information, and that actually will help with the question that you have. So every individual query text, every unique query text is being captured and stored as a separate entry. But a query is an entity in the query store that actually consists of query text and unique combination of context settings. By context settings, I mean here plan affecting settings. Those can be set options that you set in your query, like set ANSI nulls or date format or stuff like that. When you execute the same query text with the different context settings, that will be actually detected as a separate query. So you can analyze and tune them independently, right? Now, every plan that is executed, that is generated and executed during the query lifetime will be stored separately. So at the plan level, you actually have runtime statistics. So for the query, if query was executed with different plans, you'll be able to distinguish what was the good plan versus bad plan, what was the resource consumption of each individual query plan. And now, how do we store runtime statistics? It's now very important. Query store uses time window concept to aggregate runtime statistics for query, which means that every query with a plan that was executed within that time window will be represented with one aggregated row. By default, time window is 1 hour, right? So during that 1 hour, if your query had only one plan, you'll have one row in the runtime statistics with different metrics, like related to the CPU, and I'll show that later, all these runtime statistics, several statistical measures that describes how query behaved during the time interval. What is good? You can influence the granularity. You can choose between 1 minute to 1 day, right? So by default is 1 hour. We believe that is good enough for majority of workload. And all that data is stored in the internal tables, part of the database, and then expose a set of views. So I basically showed how you can use UI, but even much more richer experience you can have by exploring these views, starting with the query text, query plan, and then combine those with runtime statistics that actually hold information about how query executed over time. So this is the set of information that you'll find available. On the compilation side, you have timestamps of the compilation, count of compilation, or the duration, and many other metrics. On the execution side, you have metrics that are here that you see on the slide. But what is important, execution type. It's very important. So not only that query store captures the statistics for the finished queries, but also for aborted queries, client aborted queries, and the queries that failed due to server-side exception. So basically, that's very interesting. Now you can you can see what is typically invisible, right? You have queries that are failing. You do not know how much resources they use. Now with the query store, you'll be precisely, you can precisely measure basically how much of resources your application is wasting on nothing, right? And that's definitely something that you want to improve. When it comes to all these metrics that I mentioned, on the execution side, we do have and we do provide duration, of course, but also CPU time. That's something that you're able to see. Different I/O metrics, metrics related to CLR times. You'll see the actual degree of parallelism that was used for the query execution, memory, and row count. And all of these actually are expressed as a minimum, maximum, average, standard deviation, right? So you have full statistics in place to do your analysis. Also, the last execution timestamp is part of the plan and query view. So you don't need, if you need only the information when the query was last time executed, you don't need to go into the runtime statistics. Now, here is how query store is actually populating the data. This is the logic that is used behind the scenes. If statement is not stored, if statement comes for the first time, then actually query store creates different entries. It entries the query text, the context settings that were used for the query execution, query plan, query everything that was generated during the compilation phase, right? Oh, this is the compilation phase. If statement was in the query store and it is compiled again, then the query and the plan will be just compiled and updated, right? If statement comes into the store under the new context, that's something that I mentioned previously. So you executed the same query text, but with different ANSI option. We will record the new context settings combination, new query entry, and new plan, of course, will be generated for that. And finally, if statement is in the query store, but new plan is being generated due to the recompilation or whatever, it will be stored and the query data will be updated. So this is the runtime part of the story. When plan in store is executed for the new interval, now this is important because, as I said, query store automatically maintains time intervals. Granularity depends on the settings. Default is 1 hour. It can be more granular. If new interval needs to be open, then actually query store does a couple of things, right? It opens the new interval, generates a runtime statistics entry, and then records the information in the plan about the last time execution. If again comes a query within the same interval, what happened? Query store just updates the statistics for that entry. So it doesn't accumulate data. If you have 1,000,000 times executed query within 1 hour, you'll have only one record in the query store. That's the point. So that's the reason why I mentioned execution part is not that critical, whereas the compilation part is much more critical. Okay, and now how data is being stored on the disk. This is also important. There is async process that moves the data from the query store memory to the disk, and this is the implementation that guarantees the minimum performance overhead you have, right? Because in-memory operations are very fast. When you need to capture new query or to update the runtime statistic, that happens very quickly. And then async process takes the data and stores in the table. But basically, that doesn't affect the way how you see the data. When you query the query store data, you'll see always unified the data, always the latest state. If you executed query a second ago, you'll see that in the query store. No delay. That's important. And then, what are the queries that query store track? You should have that information in order to understand better what are the type of queries. So any T-SQL data modification statement, and by DML statement, and not only that, as I mentioned several times, doesn't depend whether the statement is cached or not. Even if query is all the time recompiled, it'll be in the query store. Every new plan will be stored in the query store. Even if you set optimize for ad hoc queries at the database level to just filter out the noise in the plan cache. Those queries will be stored in the query store, and some internal queries as well. As part of the storing the information about queries, query store also tracks the information about the containing object. If you are running the query within the store procedure, you'll get the information, what is the store procedure that contains the query, or the trigger, or the function. Now, when you have multiple statements in your store procedures, every statement will be a separate query in the query store. If you force a plan for a statement, for one statement in a store procedure, and store proc has multiple statements, only that statement will be with a force plan, right? So completely independently. A very, very big level, a very, very fine-grained level of granularity, right? If your statement is parameterized, meaning you use client-side parameterization, or you use the database parameterization, it will be stored in the parameterized form. Now, in the query store are select, updates, insert, and deletes. Out of the query store are DDL statements, bulk inserts, and different comments. So you won't be able to find them there, right? A few words about query store maintenance, because you should spend actually some time maybe configuring, if you wish, the query store to reflect your needs the best. So there are a couple of knobs available for you. You can enable or disable query store. You can change the operating mode. And all of these changes, not only that are available through the UI, but also through the DDL, and also reflected in the database query store options. You can go there and see what happens. Previously mentioned, you can set the size limitation. If you hit the size, it goes to the read-only mode. Also, best practice is to use the capture mode auto and the size-based cleanup. Of course, if you have environment where you want to track each individual query, if you suspect that you have ad hoc workloads, set capture mode to capture all queries, analyze them, and then decide what you need to do. And also, there are low-level store procedures that can be used to managing and maintaining the query store. You can delete individual query from the query store, or individual plan, or you can clear the statistics for the plan or the query. So there are very low-level procedures. Now, a couple of information related to query store in Azure SQL Database. Definitely, query store capability-wise is completely identical to SQL Server. And not only that, query store was really a true cloud-first feature that we first shipped in the cloud, delivered to our customers, collected a lot of feedback, and tracked a lot of telemetry with regards to how it works, and then fix those things and incorporate that in the box version of SQL of the query store. There are a few differences when it comes to the default configuration, because we do control query store, how it works in Azure. We do adjust the optimal configuration, and we are currently in the process, as I mentioned, of automatic activation for all databases in Azure. Very soon, query store will become on by default, which means when you create a new database in Azure SQL Database, query store will be up and running. It's still not the case in SQL Server, but we are working on that to happen. What we want to achieve actually is to introduce, basically to test heavy workloads on-premise in order to make sure that query store is really, really like introducing minimal overhead in all edge cases that we're currently testing. And a very important thing for the query store in Azure SQL Database, it powers different features. So, for instance, Query Performance Insight, which is available on Azure portal. When you have issue, you don't need to open the SQL Server Management Studio. You can, from the portal, see top resource consuming queries, queries ordered by the number of execution and some other metrics through using a nice and intuitive UI, but also features like Index Advisor that you probably heard of. That's the new service that we have in Azure SQL database. It recommends indexes for you, and it uses query store in the validation loop. And also some new features that are in the works will also depend on the query store. So before I move to the second demo, any questions with regards how query store works and how it collects the data and clusters? Okay.
So
Yep.
none of the parameters are actually stored that are passed in.
Sorry.
None of the parameterized queries with the actual parameters are not stored.
Yeah, the question was whether we store parameters. Today, we do not store actual parameter values. Yeah, that's a kind of that would be kind of expensive, right? So we are trying to figure out what is the best way to store the parameter values. Maybe because in some cases, like a parameter sniffing problem, you basically want to know what is the distribution of parameters, right? In order to correlate data information with the yeah, and basically we need to figure out what is the best way to introduce a lightweight recording of the parameter statistics. Yeah? Query is part of the, okay? Yeah. Yeah, so the question was if query comes from the store procedure, my understanding your question was, can you see the name of the procedure? Yes. So object ID is tracked as part of the query object. So basically you can join the query object with sysobjects and get the name of the object. And also a new version of SSMS will show that information automatically. When you select the query, you'll see the information. And not only that, there are some other things like you'll be able directly from the query store to navigate to a target store procedure and modify the code. The code will be highlighted in the store procedure. I think that change is very soon will be available. Yes?
I was unclear on this slide. Is the difference that it's on by default in Azure and off?
So yes, I said query store in Azure will be on by default very soon. We are in the process of activating query store in all databases. As I said, it's running around in around 1 million of databases today, and it will be soon very soon on by default. And we are in the process of basically making sure that it works reliably for the on-premises environments. When I say that, I mean high-end machines, critical, big machines, and stuff like that. So we are testing query store extensively to high-end configuration to make sure that it works good. It's not on by default in box. Of course, you can enable it, and we do recommend you to enable it. As I mentioned, one of our customers is actually on-prem customer. It enabled query store in around 60 or more databases, right? So, yes? Yes. Yes, sorry. So the point is, for every query that was executed with an interval, right, let's say within an hour, you have all information about duration, last time execution. When I say duration, I mean minimum duration, maximum duration, standard deviation, average duration, a set of statistics, right? And then the same for the CPU time, for memory, for disk I/O, read, writes, for DOP. All of these metrics within interval are represented by 5 metrics, right? Minimum, maximum, average, standard deviation, and total, or last value, right? So you have really rich data set that you can analyze. And actually, that's the point of my next demo. More question? So the question was, does it work for natively compiled code? Yes, query store collects the data, and you can use it to monitor natively compiled code, although plan forcing doesn't work for the natively compiled code, but mostly because you cannot actually force the plan for the natively compiled store procedures. But you can use it to monitor your in-memory OLTP workloads. Okay, I think I can show you demo to give you some ideas. The next demo is actually about using query store for rich data analysis. But before I go to that point, I want to check my email. Yes, so what happened, this plan forcing actually helped. And if I go to the database, I can see the drop. The expensive query caused almost 60% of the DTU. And really, that sometimes is the case. And you can use this as a mechanism, at least to quickly mitigate the problem, to buy some time, to go to the application, and then come up with the best optimal solution, right? So this is what I wanted to show you today. I mentioned there are a couple of views and stuff that you can directly query. But even without directly querying query store, you can use tools, BI tools, to access this rich data source and actually come with some conclusions. I will tell you the very realistic story. We are currently in process with one of our customers who is complaining about bad performance in Azure SQL database. Those customers are running, let's say, analytic type of workloads. So what they do, they collect the data from different sources, like with a frequency every hour. They dump the data inside the database, and they're running constantly queries. They serve many customers through the dashboards. And what they complain about is actually they said to us, you know, our queries are slow. I mean, our reports are slow. It should run for at least second or last, but actually they run 5, 10 seconds, and you figure it out. We don't know what the problem is. They also said, we do suspect that the loading process is not a problem itself, but we think it might be using a bit more resources than we expected. And that's everything that they said to us. And they exported the query store data and gave us for the analysis. That analysis is currently in progress, and it's quite interesting. But here is how I approached the problem. I took their data and then tried to basically derive some insights to see what happens with their database. Everything that I've heard from customer, I just told you, so I don't have more details. I'm using query store to conclude other details. Here is, I loaded the query store views here in the Power BI. So I promised myself I'm not going to write any query today against the query store. You are DBAs, developers, you know how to write good queries, just do that. But the idea is you can use BI tools to derive some very, very valuable conclusions. What I did initially, I wanted just to understand the daily profile. They gave us query store with a couple of days of data, like 7, 10 days of data, and I just wanted to see, hey, what is the trend in terms of CPU consumption, in terms of execution consumption, a number of execution. And it turned out that the second day is probably lower, but other days, nothing that will actually be too much concerning when it comes to execution profile. Similar workload every day. So it is not that they have problem in a particular day. They typically complain in general about the performance. So what we've done after that, since they told us the problem is in the select statement, right? Their reporting queries are slow. We did a breakdown of all their queries. And this is basically how we did. In the query store, you don't have that by default, but you can use quite a simple query to figure that out. Since we do capture plan, you can use this quite a simple query to go into the plan, extract the statement type, and then use that to basically separate queries per statement type. And this is what we see. I will just move that up. So for every plan, query ID, I have statement type, so I'm able to actually break it down. Query ID, plan ID are internal query store identifiers. Besides that, we do store plant hash and query hash, so you can use those as a unique query identifier across databases. For instance, if you have development and the test and the production database, query IDs may not be the same, but query hash and plant hash will be the same. So you can use that to actually go and correlate stuff across databases. But I just wanted to show you how we came up with this. So this is the insight, very valuable. This update statement is executed like 61%. There is some really, really big update that is going on. That was the first insight that we got. But also, we wanted to see how that correlates with the user experience, and we were quite surprised to see that merge actually takes most of the time in the database, although it's not that represented here by in this type of breakdown. Very interesting, we continued our analysis to see what else is available, and then see that, hey, when it comes to CPU consumption, what is going on? Update is really expensive. Merge statement is really expensive, and select statement actually do not take much resources. Perhaps they are actually a victim of loading process that is taking all of these resources. So that was the assumption that we wanted to actually confirm. Then the next diagram, I did a different type of breakdown. I said, hey, I have query store that can give me information about finished and unfinished queries. Let me see if there's anything strange there. And I was quite surprised to see that a huge number of their queries are actually aborted. I later remember they told me they have a retry in their loading system, right? They're just repeating the loading queries. Queries are failing like crazy, right? They do not notice that, right? Didn't notice that. If you go to the CPU breakdown, you'll see here that 33% of all CPU consumption in their database is completely wasted for nothing. Those are the aborted queries, right? So something big is going on. Again, the analysis is very simple. This is just a matter of putting a couple of these indicators to the Power BI to get this nice visualization. This is awesome. And then I wanted to see actually what happens when I did a cross-analysis between the execution type and the statement type. Update is a good guy. It regularly finishes. It's a good guy. But then there is this guy aborted, which is merge. Looks like merge is only one that actually fails. Other statements regularly finish. So merge is a problematic one. Let's go further. What we can conclude. Basically, this analysis will, I think you can do that in 15 minutes, right? Then I wanted to focus first on update because it was very heavy. This update was CPU heavy. I did a breakdown per different queries, and I realized, although I have, I don't know, tens and tens of different update queries, there is only one guy that takes 99-point-something% of all DTU and CPU, right? So there is one query to focus on. Others are really not important. I mean, if you think about how quickly you can drill down to the really necessary level of details, this really changed the way how you do performance troubleshooting. In this case, is longer-term optimization. This is not a troubleshooting. This is, hey, improve my database, do whatever is needed, right? Then the next drill down. Let's see this update query ID 20. What does it doing? I'll actually maximize this. I did breakdown per plan, and this query had a couple of plans. When it comes to CPU, this query was very, very expensive. And the second one, 186, were also expensive. Other queries very cheap. When it comes to average CPU, again, the similar situation. But then when I added another dimension, which is how many times query was executed, I actually concluded that this very cheap query, 443, was executed a vast majority of time, while other queries that are actually the worst one, 391, was executed very small number of times, but yet it used the majority of resources. For us, that's the indication that we must prevent system to use this plan. Doesn't mean that if needed, we will force some other plan just to prevent system to take this plan again, because it's very, very dangerous plan. It is executed a small number of times, but yet it took a lot of resources. Plan forcing, in this case, looks as a promising solution to solve this issue. Just quickly to show what happens with the merge. So this is the situation for the merge. Again, several queries. 83 is by far the most expensive. By the way, those are the realistic data. I didn't invent this. So this is the best part. This workload exists, right? And then I just did a breakdown, aborted merges. There is one 83 guy who is actually failing all the time. It uses the largest part of CPU and fails all the time. I did also a breakdown and realized that 83 only 10% of time succeeds, and 90% of time it fails constantly, right? So definitely for this query, we need to do something. Breakdown per plan, additionally for this query, showed us that there is a plan 402 that actually is executed with the biggest frequency, and yet that plan was one that is failing the most. So the focus for us will be to understand, the analysis is not yet finished, but basically the focus for us will be to understand why this plan has been generated, why it is taken, and how to prevent system to take this 402 plan. So this was a kind of illustration what you can do without any query. Just use the Power BI, just use the reporting services, generate queries, and get insights very fast. And actually, that can help you greatly where to put your effort and energy when it comes to performance troubleshooting. I'm closing this very quickly because we ran out of time. I just want you to basically take some conclusions from this. Remember, Query Store is a workload data recorder for your database. It will capture everything that you need. Use it as a starting point for the analysis. In most cases, you'll be able to finish your analysis only by using the Query Store, without using any other tool. That's very important. It will save you tons of time and energy. And finally, it is a tool that will give you full control wherever you run your workload, whether in the cloud or on-premise. Try out Query Store. Try out other performance troubleshooting features that we have. We have a lot of online documentation available. And if you have any comments, suggestion, please let us know. Yeah.